So today we will be solving this question, which is about proving. So as you can see here, we can equate these three expressions to each other, and with that information we need to be able to solve this. Alright, so what you can see that this variable and this variable, and you can see this is b plus c and this is b minus c. Maybe that will give you a clue about what you can do with b plus c and b minus c. Alright, so what we can do, since we know that all of them are equated to each other, we can equate to one common variable. And let's assume that the variable is k. Okay, so what we can do with that information, we can say that x equals k times b plus c. And this also applies to the other three expressions. Okay, so now we can see that we have this information. And so what we can do with this information, let's just substitute each of these variables in the main equation. Okay, so this is our LHS. Now, as you can see that this is a difference of two squares, and it's not just for this, it's for all of them. So let's just simplify this further. Since we simplified all of these, we can also simplify this further by multiplying k. Now what we see here is that we have kb squared minus kb squared minus kc squared plus kc squared minus ka squared plus ka squared. So what would that mean? That would mean that these cancel each other out because they're the same. So our answer is 0 of this expression on the LHS, and we know that the RHS equals 0. So it's hence proved.